Newton's second law of motion, the relationship between acceleration and the resultant force on an object. Newton's second law of motion states that when a resultant force acts on an object, it causes that object to accelerate in the direction of the resultant force. The aim of this experiment is to investigate the relationship between this acceleration and the resultant force on an object. We expect that as the resultant force on the object is increased, the acceleration also increases.
Still on Newton's second law, this time looking at the relationship between the resultant force and acceleration. The setup is pretty much the same, but what we are going to do this time, we are going to increase the mass of the hanging mass piece. Remember, we said that if we ignore friction is our resultant force. So what we are going to do is we've got some mass pieces on top of the trolley, and we're going to move these to hang over there, and that will be our runs. We have got 0.98 newtons, and we've got 300 grams on top of the trolley. There's your acceleration graph. Now we increase this to 200 grams, which means we have now 0.98 newtons times 2, and we still keep this so that the mass of the system remains constant throughout. Have a look at this one. I'm sure you can clearly see what's happening. Increase the force to 0.98 times 3. Put the 100 gram over there to keep the mass of the system constant. Run 3. All right. And our last run, we have now 4 times 0.98 newtons. If we take a closer look at our results, there are your acceleration graphs. Run 1, remember the force was 0.98 newtons. The value for acceleration there is 0.49. Run 2, where the force was 1.96, your acceleration value has gone up to 1 meter per second squared. Run 3, the force was 2.94 newtons. The acceleration value has gone to 1.52 newtons. And the last run, run 4, with a force of 3.92 newtons, the acceleration went up to 2.13. Now maybe you can take this data and plot a graph, this time resultant force versus acceleration.
If we plot a graph that shows the effect of the resultant force on the acceleration of the trolley, we get a straight line that goes through the origin. This tells us that the acceleration of the trolley is directly proportional to the resultant force acting on it. This verifies Newton's second law.